Hello everyone, I'm Archikosa. So I'm about to discuss with you root finding methods for nonlinear equations. So in this case, we are finding the values of x for which our function f of x equals to 0. So under nonlinear equations, so there are certain functions where we cannot use either quadratic long division method, or you need to find the value of x for which the function will be 0. So that's why we'll be forced to use methods like simple iteration methods, Newton-Raphson, bisection, and also secant method. So can we start with simple iteration? Hello, welcome. Root finding methods. So in this case, we'll be solving for x where our function f of x is equals to 0, given that f of x is nonlinear. So there are certain functions which cannot be solved using either quadratic or long division methods in other methods which you used before. So for an example, if you are requested to find a root for this function, so to find the values of x, so we'll have to use iteration method. So in this case, here we're going to use our simple iteration. We can use bisection method, we can use secant method, and Newton-Raphson method. So it just depends. So let's just start with the simple or the fixed iteration method. So we have to find the root for us. So but in order for us to know where to start, or the initial start, we just have to draw the functions for where x is equal to phi of x. So in this case, we're going to generalize this as our simple iteration method to find the next root. Until we find the root, we'll be just iterating this way on the same equations. But where we see our value started to be suspicious, to be constant, and that will be basically our root. Another thing you have to know about this simple iteration method, once we have found our root will only converge if, or else it will diverge. So let's just begin. So the first thing first, in this equation that we're having, x squared minus 10 ln x equals to 0, we'll have to express our x in this form. So if I look carefully at this equation, I have three possible ways, which are, so these are the three equations which I have achieved. So the first one, I have x is 10 ln x over x. So I'll indicate this to be my phi 1 of x. So the second one is plus or minus the square root of 10 ln x. So this will be my phi 2 of x. And the third one is given by e to the x squared over 10. So this will be my phi 3 of x. So considering the iteration table, so we consider our functions phi 1, phi 2, and phi 3. So here we're going to find the roots for each. We find the iterations. So these are my iterations. So it will depend on how many iteration and depend starting on the initial guess. So I'm defining my next iteration by 10 ln of the previous divided by the previous for the first column, and for the second column is just the square root of 10 the ln of the previous. So for the third column is e to the power the previous squared over 10. So as you can see, so that's how it is. So I just have to choose my initial guesses for each this. So for the first one, since it's a ln, so my initial guess is the value that I assume, the initial value that I assume that is before the root. So in this case, I'm going to choose 1.5. The reason being, if I choose 1, it will make my next iteration to be undefined, since ln of 1 is 0. And if I choose anything less than 1 or between 0 and 1, I'll have a problem. So in this case, I can choose anything bigger than 1, but I just chose to choose this. Even similar case on this one, but allow me to choose my initial guess here to be 2. So here I'll choose my initial guess to be 0. It does make an appropriate sense, so you'll understand. So I'll just have to find all iterations for this 3. So for the first one, starting at my initial guess here, what I'm going to do is to follow this one. The next iteration is 10 ln of the previous iteration over the previous iteration. So my initial guess in this case, you can see, is 1.5. So I'll say 10 ln of 1,5, then divide by 1,5. And I'm going to get my value as 2.7031, which is my x1, iteration 1. So for iteration 2, I'll say is 10 ln of iteration 1 divided by x1. So the same thing as I did. So not to waste time, what I'm going to do instead, I just have to come here back and put answer, that I don't waste time again to fill up the left gap. So the second one is this value, as you can see. For the third iteration, I get this value. For the fourth iteration, I'll get x4 is given by 10 ln of x3 over x3. That's how the process is going. So if I proceed, I just click the answer here. So my x4 will be this. x5. Proceeding further, x6 as I'm doing. x7. Then this is my x8. So 3,5656, and this one is my root, because if I continue, you can see the value is not changing, coming back to the same root. So I'm done. So let me do the second one. So I'll have to start at 2, the same process I've done. So which means here my initial guess is 2. I'll say 10 ln of 2. Then I'll get the answer. For x1, it will be given by the square root of 10 ln of x0, so which is this value 2.6328, since it's 276 round off to 8. So the same, not to struggle, I'll just put answer by now in the moment. What do I do? So I'll get my x2 as a square root of 10 ln of x1. So this is the value. So proceeding further as we did, so as you can see on iteration 12, so the same thing, you keep on, the value is not changing, so which is the same root as this. So but for the last one, so that's how you do it. You understand the way I shown you, you can partially calculate. You see on the 12th iteration, that's when, so for the second one you find your root on the 12th iteration, but for the first one you find it on the 8th iteration. Can you see what this is different, but the values are the same. So let's see for this one, for initial guess, where our xk plus 1 is defined by e to the power x squared of k over 10. So how do we do it? So to make this simple, I'll start by saying 0, then I say answer, for in case I don't delay. So this I'll have, in this case, so we'll have answer squared divided by 10. So x1 is given by e to the power x0 squared over 10, so which is equals to 1. So for x2, as I did here, I'll just say answer, then I'll get this value as you can see here. For x3, I'll get this value. For x4, I'll get this value. For x5, I'll get this value. For x6, I'll get this value. For x7, I'll get this value. For x8, I'll get this value. So you can see the value. So which means at iteration 9, my root will be 1,1384. So that's how proceeding it goes. So my root will be this constant going downwards. So in other ways, I only have two roots, which are 1,1384 and 3,5656. So now I can proceed and test for the convergence of the root on each and every phi. So which means I'll have to drive phi 1, phi 2, and phi 3. So did you see how the pattern goes? So the pattern for this is defined by this, and for this is defined by this, and for this defined by this. It's an easy thing in your calculator. So can we test for convergence now? So since you know that my phi 1 is given by 10 ln x over x, so we're going to use quotient rule to drive. So phi 1 prime of x is d over dx of phi 1. So in this case, we'll have to drive the numerator, which is 10 ln x, so we get 10 over x. We multiply by the denominator, which is x. Then we subtract by the derivative of the denominator, which is x. We get 1 here times 10 ln x, which is our numerator. Then we divide by our denominator squared. So we'll get our derivative for the first phi as this one. So for the second phi, look how is defined. We're going to use chain rule. Remember, the square root of 10 ln x can be written as 10 ln x all to the power 1 over 2. So you know that. So due to that, when I drive this, it can be written as 1 over 2, the square root of 10 ln x multiplied by the derivative of the inside, which is 10 ln x. So the derivative will be 10 over x. So my final answer is plus or minus 5 over all over x square root of 10 ln x. So for this one, so you have to also drive the phi 3 of x, which is defined by this. So we should use exponential rule. So by exponential rule, d over dx for phi 3. So this one, you remember, you're going to derive the power, which is x squared over 10. And the derivative of x squared over 10 is 1 over 10, the derivative of x squared, which is 2x. So we'll get x over 5. Then we'll multiply by the same thing, e to the power x squared over 10, exponential law. So now we can just find the absolute value for each of the derivative. Then we draw that table. Then we can test for the root. So the absolute of the derivative for the first phi is this. The absolute of this is this. You can know that the absolute value function is always positive. So now we have to find out which root converge and which one diverge on each phi. So the root, remember, it only converge if the absolute value of phi of x is, of the derivative of phi of x man is less than 1. So in this case, let's try to do the first one. So what basically we're going to do in here, we're going to plug this value on the first one. So we're going to say, where we see x, we put this root, we write the answer here. So if we do so, I'll find my value here as 6.716. So my value for this root here, it will be 0.213. So proceeding further, for the second one, if I just plug this root on this one for phi prime of 2, absolute value, so I'll get the value here as 3,857, and here I'll get the value as 0,3 0.293. Lastly, the absolute value of phi 3 of x, so I just substitute my value for 1.1384 on this one here, so I'll get 0.259. I substitute this value 3.5656 in here, I'll get 2.543. So if I check here, for this to be convergent, so the absolute value of the derivative of phi has to be less than 1. So does the root 1.1384 converge on phi 1 and phi 2? How do we see? The absolute value of the derivative of phi 1 is bigger than 1, so it diverges. And for absolute value of phi 2, the derivative of phi 2 is bigger than 1, it diverges. But for the absolute value for the derivative of phi 3 is 0.259, which is less than 1. That's why I said this value only converges here on phi 3. So, and as for this second one, it converges both on phi 1 and phi 2, but diverges on phi 3, since this value is bigger, 2 point something is bigger than 1. So that's all that I have today for you. That's all that we are supposed to do. So you all welcome. Keep on subscribing. Support me at articosa.com.